Welcome to the last Playdate of the year, and I just wanted to start out. I'm terrible at doing this. Phyllis, who usually is the MC, is much better at doing this than I am, and that's an understatement. But this is the end of our 10th anniversary year, and so I just wanted to thank all of you who've come throughout the year, and the people that have actually helped put on all of ICAT this year, and just do a special thanks. And Tom Martin is sitting there, Phyllis Newell sitting there, Tanner Up the Grove. We've got, who do we got back there? We've got David Franisich and Dylan Parker, and Gustavo is over there somewhere, I think, and Kevin, and Holly and Melissa, Holly Williams and Melissa Wires. I almost forgot your last name. And Brandon. Brandon is here somewhere. He's hidden over there. Behind the screen, yes. So even the 360 camera can't pick him up. But I just wanted to thank everybody for everything you've done. This has been a wonderful year and a challenging year, and you all know exactly what I mean about that. And so I just wanted to thank you. And for those of you that helped put together the 10-year magazine as well, which turned out wonderfully and really showcased the work of all of the faculty that have just, obviously ICAT is just here to support students and faculty and the incredible work that they do across these 10 years. So I just wanted to say that. And also, I think it's amazing. This is the perfect last play date, too, because what you have in front of you, in addition to a few robots that look like they're asleep right now, we have folks from human development and from music and sound design and singing and music and industrial and systems engineering and education, and it's such a perfect example of the kind of teams that we always hope to build here. So I just thought this was just the perfect ending to a 10-year anniversary year. So with that and all that fumbling, I'm going to pass it to Phyllis to actually take over.
Thank you, Ben. Good morning, everyone. Welcome to our final Playdate of the semester. I'm so glad you're here this morning. I'm Phyllis Newell. I am the Associate Director of Educational Networks. Glad you're here. I hope you got some donuts. There'll probably be some left afterwards. When you have questions, just a couple of housekeeping things. When you have questions, wait for me to get to you with the mic, because we're being filmed this morning. We have the 360 camera here in the middle of the room, so that this is being broadcast right now and also will exist on the internet afterwards, so behave appropriately. If you are here, and let me say good morning to those of you who are watching online. I'm so glad you're here. Feel free to move your camera around to see the whole room and to see more of the screen or less of the screen or whatever. So if Professional Development Network credit is helpful to you as a faculty member, if you'll just check in with me, if you're online, if you'll just shoot me an email or use the questions link online to let me know that you're here, that would be helpful to give you that credit. And if you're here, just let me make sure that I checked you off. In the way of announcements, we're nearing the end of the semester, which means it's almost ICAT Creativity and Innovation Day. As a matter of fact, it's Monday. So Monday from 10 to 2 here in the building, and also in a couple of other buildings around campus, we'll be highlighting the ICAT projects and people who are doing innovative and creative things, including robot musical theater. So I hope that you'll be here for that. 10 to 2 are all the exhibits. At 3 o'clock, we'll move over to the Creativity and Innovation District Living Learning Community, to the Community Assembly Space for an abbreviated fashion show, and then a panel discussion, which will be amazing. One of our last week's Playdate was one of our speakers. So I hope you'll be there for that, and then we'll, at the end of that panel, then we'll give out the awards for the day. So with all that, I thank you for being here, and I'm going to turn it over to the Robot Musical Theater team. Good morning.
Okay, thank you, Phyllis. So we are the VT Robot Musical Theater team. So the most important message, this project has been supported by ICAT and Center for HCI. So this project has two big parts. One, robot theater after-school program. Another, robot musical theater for climate change education at the Cube here. So let's get started with the after-school program. In collaboration with Superintendent And SENI liaison here, Chelsea and Phyllis, and Boys and Girls Program in Western Virginia, we chose Eastern Montgomery Elementary School, so we did 13-week program last year. So the whole goal is to promote STEAM education. STEAM is STEM plus arts and design by using social robots and arts as familiar materials. So to this end, we did modularized approaches. So we had acting module, dancing module, music and sound, and drawing module.
Hi, I'm Chelsea with the Center for Educational Networks and Impacts. Here you can see we had several robots that participated in this program. We have Pepper, Now, Milo, Quincy, Pleo, and Aibo. And what they did was we used these robots, our Virginia Tech researchers and students programmed them so that they could dance and sing and act, and the students drew. They made costumes for them so that they could then become actors in a commonly known children's story, The Wizard of Oz. We also did research throughout this educational outreach program. Every module, we did a survey with the students. We did pre and post program surveys with the students. We also did interviews with the after-school program staff and teachers. A total of 16 students, 10 boys and 6 girls, ranging from 3rd to 5th grade, participated in the program with an average of 7 students attending each week.
So this is how the classroom is usually set up like during the program. The robot that you see in the center is called Now. Now was always the robot instructor for the kids, and my undergrad and I are always behind them to control them. This is an example of children playing the music box with Pepper. And this is a music piece made by the children using Makey tools. These pictures were from the drawing module that got to draw with Quincy, the robot artist, and they also created costumes for the robots. During the free play time, they also got to play with Aibo and Pleo. And this is a video clip from our final performance. As you can see, 5 of the robots were the actor for the play, and children also got to act as the rest of the characters. And they also created costumes. As you can see, Milo is wearing the Dorothy costume, and they also created the background music you just heard. So now I'm going to talk about the results from our program. In our module survey, children rated a very high engagement score throughout the program with an average of 3.5 out of 4. And they also judged they had enough time to interact with the robot with some variability, but overall it's very high. So dancing was the lowest and drawing was the highest. So did the program increase children's interest, curiosity, and confidence in robots and STEAM? The answer is surely yes, because all children answered their interest in STEAM will increase, and their ratings for their curiosity in robots and confidence in STEAM were very high in the pre and post program. We also analyzed their interview data through a method called thematic analysis, and we found 4 interesting interview themes. The first one is enthusiasm about social robots. They always have positive attitudes towards robots, and they also show desire to have robot as a company. And then the second one is human-robot interaction advantages. They thought human robots or social robots could contribute to the society as a benefit and also make human lives better. The third one is anthropomorphism. They always put human characteristics into our social robots. And finally, we have robot design mechanisms. children wanted to learn more about robot programming and the manufacturing about robots. And I'll pass to Ariana.
I'm Ariana Wyatt from the School of Performing Arts, and the second part of what we did was an in-person event in November as part of the Virginia Tech Science Festival. And the primary objective for this performance was to educate children about the effects of global warming. It wasn't to, in our efforts to do so, we wanted them to understand that the point was that we all have to work together in order to change what is happening to our planet. So in that design, we decided to feature 4 elements, each of which were represented by a robot. So we had wind, fire, water, and earth. And here is, I guess there's one later. This is a picture. You can see each of them.
Thank you. I'm Tanner with ICAT. So the Cube was the perfect place to prototype this project. We could create virtual sets for our robots to perform in front of with this 360-degree cyclorama. That's the projection system that we're using to project on today, and we had the whole thing down on the ground. So once you come into the room, you were fully immersed in the robot's world. Additionally, we have 140 loudspeakers in this room, and we used localized sound as part of the presentation. So when the audience moved to a certain quadrant of the room, it would trigger multi-channel sound effects playing. And to do that, we used the motion capture system in the room to track movements. And some of our audience wore hats with reflective markers, so we could track their location in the room in real time. And here's the picture of the 4 robot elements. We were able to swap out those backgrounds pretty quickly and try out some different visual effects to tell our story. So that was a nice feature of the cyclorama. And back to Ariana.
We had 4 girls and 2 boys, and I had 14 visitors that came, and 140-ish people watched online for the event in November. Of course, we were prohibited by COVID and numbers in November, so we had to keep it pretty small. Ideally, we could have more people come in as we come out of the pandemic. Here's a little clip.
Let us hear your voices. Your voice is important. Say, I can make a difference.
I can make a difference.
Too small of
I cannot
numbers.
hear you. Say, I can make a difference.
I can make a difference.
Yes, it is working. Don't forget your voice is important.
I think that the biggest takeaway that we took was that the robots, when they spoke, it was hard to understand them, which I think that you heard. So in our newest iteration, we actually have humans speaking and the robots representing that with movement in the hopes that that becomes a little bit more understandable.
So I'm Cohen Choi. I'm Human Development and Family Science. So I'm going to talk about where we are now and we are going from here. So currently we are working on 2 projects. So one of them is we created a preschool version of child robot musical theater. So we are working with younger children to create this musical theater show. And last Wednesday we just did a performance. This was a lot of fun. And then tomorrow we will be doing a robot musical theater show here as a part of a VT with Perpsum seminar. So my graduate student Suchi will talk about the child robot musical theater program at the Early Childhood Center on campus.
Yes, so in CDCLR, there are 3 classrooms. The smallest kids are in the blue room. The smallest one are 17-month-old, and the oldest one in orange room are 5 years old. And this is our classroom settings. We create a storybook, which the main characters of it are all of our robots. And we read the book to the kids during our each module. And after that, we let the robots to show what they can do. After the kids see what the robots can do, they can freely interact with all of our robots with the guidance of our research assistants. So you can see the kids are automatically divided into different small groups based on their own interest in different kinds of robots. And in each small group, one of our research assistants are there to guide them, to show them how to interact more with the robots.
Last but not the least, we would like to thank our awesome collaborators. It's a truly transdisciplinary effort. And also, we would like to thank the participating children, teachers, and parents, and also Virginia Tech Center for Humanities, ICAT, and CHCI for funding our work. Thank you so much.
You'll keep that? Oh, yes. I've got it. Well, thank you. I really appreciate how transdisciplinary this project is. It is really, Ben said it well, that it's really getting at what we want to do at ICAT. It is time for questions. So if you're watching online, if you'll just use that questions link, and I'll get your questions here on my computer and relay them. But if you're in the room, just wait for me to get to you. Who's got a question this morning? I'll start off, though. I'll come to you in just one second. While I'm getting there, can you all talk about what is happening at ICAT Creativity and Innovation Day with this project?
Take that. Does anyone want to? At ICAT Creativity and Innovation Day, we will be in this room, and it will be open house, so you can come and talk to us about the project. We'll have some of the robots here, so you can come and see them and ask questions about the robots. We'll have some of the digital scenography we made for the performance up on the cyclorama and some of the sounds going. So you'll get a taste of the performance. We'll also have some information about the after-school programs if you want to know more about that. So it's kind of come and meet the team and hang out and chat.
Awesome, thank you. Do you have a question?
What was the hardest part of making the robots in the performance? Or with the coding?
I think the hardest part is to make the robot's movement and speech synchronized. So to make their movement more natural, you need to have the visual and auditory cues in a synchronized way. Otherwise, it will be very unnatural, and which might cause uncanny valley, which is seeing human-like beings being so weird and creepy, just like this one. And then, yeah, so we could make them to sound more natural, look more natural by making the synchronization, and which took a lot of time.
I have to say that they did a great job. So I made videos of myself saying the text and gesturing how I wanted the robots to look. And then they had to do that. It's such an easier part. But it was very hard. And then some of them, we tried to put facial expressions in Milo, and that just creeped people out. So we took those away. But, you try things and you try to figure out what's going to actually read in the room and what's not going to read.
Excellent, thank you. I'll come to you, Margaret.
Thank you for this presentation. It's so wonderful. I wonder, for the older kids, did you pick up on any of their own experiences with or impressions about robots that they brought from, maybe the media, and what did you gather from that?
So we noticed that a lot of them think robots as humanoid robots, not like machines. So they always mention the anthropomorphism of robots, which they think robot could talk, move, and drive is their common sense. But not every robot could do that. So in the program, They really got to know the robots, and at the end, since our robots are more humanoid and their impressions on robots are more they are more sure that robots are humanoid, not the machine kind like the robot arms in the industry. So yeah.
Thank you. Hi, Jamie.
Hi. Can you bring one of the robots to life?
To light?
Yeah.
Oh yeah.
Yeah, can we turn them on?
It might take a while.
Maybe that, take 3 minutes. You can try.
Oh, this one as well. Yeah.
Turn on briefly.
I see some waking up happening.
Yep.
Okay.
Yep.
Pepper's thinking about it.
So be ready. Milo is going to be very proud of his IP address. Don't be scared.
Milo still has the necklace from.
Yeah. Doesn't.
Do they respond to voices?
Oh, wait.
Do they respond to voices?
So unfortunately, not Milo, but Pepper, yes.
Pepper looks sleepy.
Pepper does look sleepy.
Tired.
Pepper is currently dreaming. Yeah.
I've successfully connected to the network. My Wi-Fi IP address is 172.29.78.159.
Yeah, here we go. Yeah, all of the robots are pretty dramatic, in my opinion. Always have music when they turn it on, yelling out IP address. Okay, so I'm gonna show a little demo of Milo's facial expression. So this is a denial. And then happy. Milo could also do some movement. And I'm gonna show you kids' favorite.
Hi, Pepper. There's Pepper.
This is driving. Should I also show Pepper?
Yeah.
So for Pepper, you can do music box, and then they also love this one.
I love this one.
Yeah, Pepper loves this one.
That's how I start all my mornings as well.
We do have a question that's come in online. Carl's asking, what were the most logistically challenging parts of this project? And were there any elements that were consistently challenging for the students?
So other than the synchronization, I think it was also difficult to manipulate the robots with the people in the backstage. Well, we're all in the backstage, but we have to wait for attendance cues us to do robot and to make the process more smooth. And I think that's like the most challenging part of the program. And another one for another one for the after-school program though. I found it very difficult to interact with kids at beginning. Like they are very unpredictable, and for the younger kids, they were very attached to me at one point, and I was very surprised. And I really have to take like lessons from the program from last year. That I have to talk in a very positive way instead of telling them, don't touch the robots. I would tell them, how about we interact with the robot in a different way?
So another logistical problem is, I mean, like in any other project, it's communication, right? So we have to communicate with all the parents. We need to get parent consent, and from child, we need to get child assent form. And we try to do that like 2-3 weeks before we start the program. And that was kind of one of the challenges. And we also wanted to do some interview with parents, so follow-up interviews. But obviously, they just come and then pick up their child and then disappears. So it's very difficult to do the interview with parents.
This is very qualifying for me. So they're programming robots to do theater, and the hardest part is the permissions with the children. So just saying, that's awesome. Thank you.
Yeah, and also we want to sort of evaluate how children think about this robot, how much they're engaged. But I mean, it was actually hard to pull children out because they were so into robots. They want to spend more time with them. So they felt like even bored like answering our questions. So finding a better way to measure their engagement. Maybe we are exploring different way. Maybe using a motion tracker to see like their level of movement. So there's more naturalistic and child-friendly way to get at their interest and potentially learning. So those are the things that we are currently exploring.
I think Pepper should ask the questions.
Right.
What other questions do you have in the room or online? Ben has one.
Which was your guys' favorite robot? Which were the kids' favorite robot? And why do you think?
My favorite robot is Pepper because Pepper is very presentable and it looks like it could be my home assistant at some point. But kids, they were actually very scared of Pepper because it's bigger in size compared to them. They hated Milo. They never want to interact with Milo because they think it's creepy. But their favorite is Ivo and Pleo because they look like pets. So they're puppy and dinosaur, and you could pet them, and they love to see their interaction. And they also show a lot of empathy towards them.
Another observation is kind of interesting because when we worked with young children, they easily developed attachment to the robot. So it just happened, some kids just allocated to different robots, and when we asked them which robot is your favorite, and most of them, they just responded the robot they played with like 15 minutes. So they easily attached to different robots. We did this program with undergraduate students, high school students, and elementary, and now this preschoolers, and they all have different preferences, but at least for younger kids, they easily develop the attachment, which is very interesting.
Yeah, so that's actually the question that we asked to young children, which is added to this iteration. So we will present the data later, but we show the pictures of all the robots and ask them to point like, which one is your favorite. Yeah, so.
It's fascinating to me about how they choose. I love to hear those reasons about when the robot is bigger, which Pepper was clearly designed to be a small creature, but to me, because that's smaller. But for a little child, that's if it's bigger, that's interesting. And then also that if the ones that appear as pets, so then the power difference is clear to begin with. Like I'm the grown up, I'm the human, and you're the pet. That's interesting how the power dynamics work in those different shapes. Fascinating. Oh, it's time. How did the time go by so fast? Thank you all so much for being here. Thank you, team, for presenting your work both today, tomorrow, and on Monday. I know you are having a very busy week. So thank you for that. And also thank you to those online and those here in the audience for being here this morning. I hope the rest of your day is amazing. You have a great weekend and that you're here on Monday for ICAT Creativity and Innovation Day. Thanks.